Hello everyone. To this video, I am going to simulate linear voltage regulator using LTSpice software. First of all, we need to open the LTSpice software. So here is the basic environment of the LTSpice software. So then we need to create the schematic window. Here is the schematic window. You can create the schematic window or you can just press the Control N. I am going to simulate type 1 linear regulator, which has a Zener diode resistor connected in series and then the load resistor. Okay, so first I need to find the Zener diode. So under the component list, we can find the Zener diode. Here is the component, or you can just press the P. So here is the component. So under the component list, you can see Zener diode. Here is the Zener diode. Okay. So then place the Zener diode here. So then you have to rotate this Zener diode. You can press Control, hold, and then press R here. Okay. Then you have to press the resistor here, R. Then you need to connect to the resistor and Zener diode using the wire. This is the wire. You have to press the W. Okay. So then the wire. Okay. So here is the connection. So the special thing is every circuit should have ground. Okay. So here is the ground. So ground G. Press G. Here is the ground. Okay. So then I'm going to connect the load. So load here. So then finally I have to add this voltage source. So in order to add the voltage source, you can press V. So after that, similarly, the previous, I have to connect to the ground and press G. And this is the input. Okay. Now I have to give the values. Similar to the lecture note, I am going to give the values. Okay. So I have already uploaded that lecture note, so you can go through it. So here is the values. So 30 volt. So and also the 20 ohm. And so this breakdown voltage of the Zener diode, which is 10 volts. So let me select the 10 volt Zener diode. So in here, Zener diode. So and the load, maybe let me give also 20. Okay. So now I'm going to simulate. To simulate, you need to press run button. Okay, here is the run button. So after clicking, you will see this window. This window, you have to add the stop time. So I'm just give the maybe 100 micro. Okay, then okay. So here is the simulation window now, which means that now I have already run this simulation. So I can see the waveform corresponding to the any point or any node. Okay, here. See, you can see the load voltage, which is around 11 volt. But the thing is, you have to understand, I have selected the 10 volts and diode, okay? But the voltage around 11 volt. So which means that the Zener diode has some tolerance. Maybe that can be plus or minus maximum, maybe 1 volt tolerance. Okay, in here, maybe it has the 1 volt tolerance. Okay, which means the 11 volt that can use the 11 volt voltage for the load. Okay, so let me change this value. Maybe I can select maybe 100 ohm. So then it reaches to the 11.12 volts. Okay, see, it's more than 11. Let me select maybe very big value, maybe 10,000 ohm. Okay, which means that the load current will be very small. Okay, so let me run again. So you can see now the 11.3 volt. So you can see the current through the load. Okay, see, is now the milliamps. So what happened when I select very high, maybe like this is 10K, this is now 100K, this is 1000K means, which means that the 1 mega ohm. So let me see. Okay. So see, this is the voltage which is around 11.3, and the current is very less as 11.3 microamps. So let's see what happens when we reduce this value more than the minimum load resistor, 10 ohm, okay, the 10 ohm. So this is the 10 ohm. So you can see when I select the 10 ohm, so 10 ohm, the voltage around 19.99, which is almost 10 volt. Okay, so let me add the some resistor value which is less than this minimum value. Okay, maybe around 5. Let me simulate. So see, now this regulator, now this simple regulator cannot maintain the load voltage at 10 volts. So see, this is 6 volt. Okay, less than the regulated expected regulated voltage. Okay, 6 volt. So now let me explain the second type of linear regulator, which has Zener diode and resistor and also the BJT or MOSFET. Okay, so to do that, I'm going to just copy paste this diagram, because as you know, the second type is just the modification of first type. Okay, so then I'm going to copy. Okay, to copy, you have to press Control C. Okay, so then I need to find the transistor. To find the transistor, just press S. So then you will see PNP. Okay, the PNP type BJT. Okay, and then you have to rotate this one. See, I rotated. So then place over here, and you can easily connect. Now the load should be moved to the over here, and that should be connected to the emitter of the BJT. Okay, I have connected emitter of the BJT. Okay, and then now this inner voltage become the voltage reference for the BJT. Now the thing is, I have to find some suitable BJT. So let me select well-known BJT. So in here you will see 10 here the 2N3055, which is very common BJT here. Now let me run the simulation. Okay, so okay. So if you want to give this name for the net, you have to press N, then type. So in here, I'm just going to do BJT. Okay. In here, BJT. In here, just send up. Okay. Net. Send. Okay. Okay. Now let me simulate. Okay. You can see now Zener. Okay. So Zener. So which is okay, Zener 6 volt and BJT. See? Oh, really? Oh, now you can see. So even this configuration is unable to regulate the output voltage, but the modified circuit can regulate the output at around 10 volts. See, you can see now 10.5. See in here 10.5. So let me change this value. Maybe even if it becomes 1000 ohm, so still it cannot regulate around the 10 plus tolerance value of this diode. Okay, so now it's 11. Okay, but the thing is, this configuration, this simple circuit has some minimum value of R, but in here, so this circuit can go the beyond of the minimum value of this circuit. Okay, you already saw that. Okay, even I gave the value maybe 2 ohm, still this circuit can handle this voltage. See, it's around 10 volt. Okay, the 10 volt. But in here, when I give this 2, this circuit cannot handle. See, it is now the voltage of the load dramatically decreased down to the around 2.5. See in here, but in here the voltage around 10.4. See, this is the advantage of this type of linear regulator. This linear regulator can handle very small load resistor compared to the simple linear regulator that have implemented using just zener and resistor. Okay, during my next video, I will explain the type 3 linear regulator, which has not only the simple structure, which is zener and resistor connected in series, and the transistor, and also it has error amplifier. Okay, so see you next video.